Yes. Hi Devraj, welcome to Margdarshan. So,
Yes.
yes, please introduce yourself.
So, as you mentioned earlier, my name is Devra Saikumar. I'm from Visakhapatnam. I did my schooling in AU English Medium School with 9.7 CGPA, and after that, I did diploma in mechanical engineering with 91.65 percentage.
Mm-hmm.
And after that, I have joined such an Institute of Technology and Management, and I recently completed my graduation with 8.7 CGPA. And during my course of study in diploma, I have done internship at Hindustan Shipyard Limited, and also had done major project on servicing and maintenance of twin cylinder diesel engine. And in during engineering, I had did my internship in BHEL, where I have posted in R&D division, where I got opportunity to study about the plate and film heat exchanger. So I did my major project on thermal enhancement of the solar heat dryer. And my hobbies are playing badminton and learning new things. And I'm a quick learner, and that's it.
Yeah, that's great actually. That's a very good, uh, structured. Tell me about yourself. I really like that. Yeah, really nice. So, Devraj, what are you doing right now? I mean,
I, I'm actually preparing for competitive examinations.
okay, great. And when did you pass out?
2022. Sir.
Okay, so I mean, you are just, pass out and you are preparing for competitive. Okay,
Yes,
any question? So, what exactly do you want this interview to be? HR, technical, or technical plus HR? How do you want it to be?
technical plus HR, sir.
Okay, great. So, what other exams are you also preparing for?
Actually, I'm currently preparing for PSC examinations.
Okay, okay, and like let's say that you get selected in Hpcl, and then some other recruitment came by and you got selected in that as well. So what will you do in that case?
No, sir. If I got any job, I will give my 100%. I'm dedicated to the job only, sir. Like I with inform after informing that company, if they give permission, I will go to another, sir. I mean another.
Okay, so I mean you will ask for permission and then go to another one.
Yes, sir. If company accepts, sir. If it is there is upgradation like
Okay, fine.
of the current profile.
That's good. So I hope your gate was also good then. You have already qualified a return of HPCL.
Not that good, sir. Actually, I came to qualified one. That's it.
Okay, okay. That's good. So why do you want to join HPCL, Devraj?
Actually, Hpcl, which is a Maharatna company, and the diversification which it got from petroleum products to recent HP Durapol, which it entered in green energy also, and also they have set up so many EV stations. Uh, Particularly, the diversification of Hpcl made me to join, sir, and I just want to be a part of the growth and development of that organization.
That's good actually. So just a minute. Yes. Devraj, what are the subjects that you are comfortable in?
Heat transfer, basic thermodynamics, fluid mechanics, and
Okay,
theory of machines.
okay, great. So what are the modes of heat transfer, and
Conduction.
what is the principle behind them?
There are three modes of heat transfer, sir. For conduction, it is Fourier's law of heat conduction, and convection, which
No,
follows
that
the Newton's.
you are mentioning the law. I am asking the basis. What's the principle? What's the governing mechanism of heat transfer in conduction?
So
Let's say.
for conduction, it will be different for different materials, sir.
Okay,
And
like.
coming to metals, it will be. I mean, coming to metals and non-metals, it will be lattice vibrations and free electrons. And in metals, free electrons dominate over the lattice vibrations, and in non-metals, it is lattice vibrations only. And in liquids and gases, it is a exchange of molecular momentum
Right,
due
and
to temperature.
correct. And what about convection and radiation?
Convection, it is a And conduction, there is a bulk motion of fluids, sir. Apart with conduction, it is a combination of conduction and advection, where we can see both of the principles, like the conduction and in advection, we can see the heat transfer takes place due to the bulk motion of fluids, that is fluid currents. And in radiation, the heat transfer takes place due to the electromagnetic waves. I mean, through electromagnetic waves.
Okay. And does the electromagnetic waves have some speed or something like that? Are you
No, sir,
aware
it
of?
have wavelength. I mean, it at a particular wavelength, sir.
Great. So let's say we have two sources. Okay. Are you aware of okay, tell me something about thermometers. Let's say you are an engineer, you are in HPCL, and you want to, measure what is the crude oil. You are boiling a crude oil, and you want to measure the temperature. How would you do it?
Actually, for depending upon the temperature range, we will use the different types of thermometers, sir.
Correct. Can
And
you explain a
particularly,
little bit about it?
if I'm not wrong, mercury type thermometers is we can't use for temperature measurement. We can use the thermocouples to measure the temperature of very high temperatures. I mean, very high temperatures.
Correct.
Where else we can get accurate results.
Correct. And do you know how the really high temperatures are measured? Like 2000 degrees Celsius, 2500 degrees Celsius, or something like that?
Yes, sir, we can, according to equipment, equipment, it will may differ, sir.
Correct.
And coming to thermistors, we can see the resistance change. It is calibrated to measure the temperature. And in thermocouple, we can see the voltage potential. The amount of voltage potential, it is calibrated according to the temperature.
Correct. Do you know how? That's what I'm asking actually. How the 2000, very high temperature are measured?
Yeah, that's what I said, no, sir. Thermocouples, we
No, we
can use
don't use
thermocouple.
thermocouple. Thermocouple and thermistor don't work at that temperature regions.
We can use
Yes, I think you had a correct word.
pyranometers.
A pyrometer or something like that.
Pyranometers.
Correct, correct. And do you know how they are
Where
based? I mean, what's the working principle behind them?
Actually, incident of light, sir. According to the principle of light, we can.
Okay, you can say radiation actually.
Yes, sir.
Essentially it measures
Yes, sir.
what's the pulse in the radiation.
Yes, sir. Yes, sir. Pulse.
And
We
we
can use
have
the
that
pulse.
law, wind displacement law. I forgot the name. I know what it is. I know wherein we have lambda into t equal to some
Yes,
constant.
yes, sir. That's a wind displacement. It's
Correct,
a
sir.
wind displacement.
Correct. Can you
It
explain
is
about
inversely proportional to wavelength and temperature.
correct? Can you
Absolutely.
explain wind displacement law?
Actually, for a particular wavelength, actually at a particular temperature, the wavelength at a maximum temperature, the maximum temperature at a particular wavelength is inversely proportional, sir, for a particular wavelength, if I'm not
Okay. Again, can you please repeat? Take your
wrong.
time.
Or- So for a particular wavelength, the maximum temperature at which radiation occur is inversely proportional. Sorry, sir, I'm
It's
not.
not maximum temperature actually. It's something else. You are in the right direction, but a little, here and there. It's actually radiation intensity that we care about.
Intensity, yes, sir.
Correct.
Intensity.
So if you remember the graph, you know how exactly we
Yes, sir. Yes. It
calculate.
will be deflected towards the left, sir.
Correct, correct. So it
Maximum.
is it is intensity versus the wavelength graph, and it has a peak value.
Yes, sir.
And so essentially, it's the radiation intensity. I think whether it is called as intensity or not, I think it's intensity only. You can call it that way as well. Yes. Anyway, so I hope that particular thing is clear to you now.
Yes, sir.
Correct. Uh, okay. So let's say, okay, that day this was a really good question. I think Prathamesh and Bipasha who are here, they know the answer. Let's say you are an engineer and you want to have, you want to build a power plant. Okay. A
Yes, sir.
steam-based power. Okay. Can you explain Rankine cycle?
Rankine cycle,
Yes.
it is a reverse. It is a one of the power producing cycle, wherein we can see wherein the cycle is completed by two isobaric process and isentropic process and two isentropic processor, which is used for the uh, power production using the steam.
Correct. So, in reality, there isn't hardly anything like isoentropic process. You are aware of that?
Yes, sir. There is, as of my knowledge, there is no any isentropic process because for any process to occur, there may be some friction. With the friction, there may be some loss. So there is no cycle which is isentropic.
Okay. So
It
now,
should be reversible.
correct. It can be, as ideal as it can, but it will never be a pure ideal
Completely.
isentropic cycle. So what happens in a Rankine cycle if the isoentropic process, turns real, not ideal, but they become real?
I can't understand the question.
Okay. So we have isoentropic process.
Yes, sir.
In Rankine cycle, what we essentially do while calculating is we consider them to be an ideal process.
Hmm.
But in actual scenario, we don't have ideal process. We have some real processes. Okay. I mean, the reality, it's different. So can you draw a real Rankine cycle?
Yes, sir.
Yeah, draw it. Meanwhile, Bipasha and Prathamesh, you also try. Okay. I mean, don't have this question only based to Devraj. You also try because I'll be telling the answer. I'll be telling
Okay, sir.
answer. Yeah, I'll be telling the answer anyway, so you can judge whether how did you
Can
do.
you
So
please repeat the question?
yeah, so essentially, in reality, we never have any isoentropic process, a pure isoentropic process. I hope you are aware what exactly happens when an isoentropic process is executed in real life. So essentially, what I'm asking is in Rankine cycle, we have two isoentropic process. So I want them to be considered not ideal but real. What will happen? How will the curve will behave in that case?
Okay.
So it's the temperature entropy diagram, sir. We can see the dotted line here, which is not a, it's a erosive, which is not a isentropic process.
Yes, I got it. So at the where usually the exit of Rankine cycle turbine is.
Normally, ideally, Rankine cycle, we we can see the exit of the turbine is a dry, sir.
It's not pure
No,
dry.
it's not dry, sir. It's not dry, sir. Actually, at the entry of the turbine, it is a dry, sir. At the exit of the turbine, it is somewhat
Yes,
wet.
so I ask
It is
actually
a
exit of the
modified
turbine.
Rankine cycle.
Huh?
It is the modified Rankine cycle, sir, wherein we can see the superheating and subcooling also, sir.
No, no.
Whatever I draw here, it is
Okay, okay. Yes, you are right. Actually, superheating is very normal. It is done all the
yes,
time.
yes,
But
sir.
yes, subcooling is not. I mean, usually in practice we do, but whenever anything is asked in interview, start with the very basic plain Rankine cycle. Okay,
Okay,
always.
yes.
Don't bring in any type of some hardcore complexity, because what happens is they might be asking you question based on very basic things, but sometimes what happen is we as a candidate, we tend to answer things very complexly. Okay.
Yes.
Yeah. So
Okay.
draw very what essentially I wanted to see is due to the irreversibilities, the turbine exit essentially transform more onto the vapor side actually.
Dry side.
Yes, dry side, yes. And that essentially helps us, not a lot, but that
Helps us
still does help.
to reduce the erosion of plates and all, like
Correct, correct.
moisture.
Right, right,
Like
right.
that.
Exactly, exactly. So that day, this was a good question actually. Um, yes. So, why do we have condensers in a
Actually,
Rankine cycle?
condenser serves two purposes, sir. Which will condenser will increase the enthalpy drop, which wherein we can get a more power from the turbine, and on the other side we can recirculate the steam, sir. I mean,
Correct.
with recirculation, recirculate the working substance.
Yeah, so the first point is is very important actually. That's what I was expecting. Yeah. So Devraj, let's conclude your session now. Do you want me to ask some HR questions maybe?
If possible,
Yeah,
you
I
can
thought
ask.
maybe I'll ask you later. Yeah, it's okay. So I'll carry on. So as you have answered, why do you want to join SPCL? You have such a good okay, tell me something about your internship. Where did you do your internship?
In diploma, I did internship in Hindustan Shipyard Limited, sir.
And
And in
in
BTech, I did internship in BHCL,
yeah,
Visakhapatnam.
so can you tell me what was your role exactly? What were your accomplishment in
Actually,
BHL internship?
I was posted in R&D division, sir, research and development, wherein we have studied about the various manufacturing process of the various plate and fin heat exchangers, which is so compact, and the effectiveness of that heat exchanger was also very high
Okay,
for
can
the
you
heat.
give me some very day-to-day example of use of fins?
Fins we can see um, actually we can see in bikes also, sir, wherein we can see for engine we can see the fins, and
Correct,
in refrigerator also we can see backside some protrusions like that,
correct.
and that's it.
Yeah. So
Compressors,
in automobiles, like we have bike for example, what do we do to enhance the heat transfer even more?
sir.
So fins is so we have fins in automobiles essentially they enhance the heat transfer.
Yes, sir.
What do we do to enhance the heat transfer in bikes or car even more?
We can use radiators, sir.
Correct. And what does exactly a radiator do?
Radiator is just a heat exchanger steady flow energy device where we use water as a heat transfer medium, which will extract the heat from the engine, and it will be discharge, reject the heat to the atmospheric air.
Correct, correct. Okay, so I mean, so not all the time it's coolant. Sometimes, we directly pump the oil as well, the
Yes,
engine
sir.
oil. Yeah, but yes, your answer is correct. Okay, Devraj. So, number one, you had really good. Tell me about yourself. I mean, that's really nice. You well prepared. You were prepared. That's really good, actually. Second,
सर हे त्याची मम्मा तिची मम्मा होती है ना
hello, can you please mute? Yes. So, second, yes. Uh, don't say that if HPCL provide me NOC, then I will go to another organization. Okay. Once, if you are giving interview of one organization, you will be like, up to my death, I will be with you. Okay.
Okay.
Don't tell what you want to do from your heart. Okay. Tell from your brain. Okay. उनको
Okay, sir.
बताओ कि नहीं मैं मर जाऊंगा तब भी मैं HPCL में ही रहूंगा करके ठीक है so be very straightforward that no once I am here like this has been my dream place to be at so I don't think I will ever even think of going to something else. Yeah. Then yes, your why HPCL question, I thought it was little here and there. So one thing you can mention is you already have a internship experience at a PSU, so you
Yes,
can
sir.
you can have that as a point that I had I have a very good experience of working in a PSU, and essentially because of that I want to have my full-time employment or my job at PSU only. So you have that unique point. Very hardly people have it. Okay, I agree that the industry is different, BHEL and HPCL, but still it works the same. Then yes, you have really good knowledge, good understanding, and most importantly, you are able to deliver well. Okay, I mean whatever you have, it's just not in your mind, but you are able to tell as well. So that's really nice. Your technical are very sound. you should I won't say you should, but you can definitely prepare a little bit on the HR side. Okay.
Okay.
Given you have, you have 2-3 days more, and that's very much enough for HR side.
Okay.
So what I'll suggest is, you already have a good, tell me about yourself. So improve your why HPCL answer. What you,
Yes.
what you can do is, you can, write it down, and maybe think about it 2-3 times, and then, improve your answer. Because see, wherever you go, you will always be asked this question. You are today in HPCL, tomorrow you will be at IOCL, BHL, anywhere you will be always asked this question. So have a basic framework ready. Oh, you know what, this is I'm going to say. So today is HPCL, so tell it that way. If you want, write me maybe your answer, and then we can also discuss about it. Okay.
Yes, sir.
Yeah, your technical is very strong, so that's very good to have. HR, you are good, but we can always improve. Mostly the questions are, half HR, half technical, so it's not a very technical focused one. Okay. So Devraj, let's conclude your session now. So can you please, give a little review about how did you feel, overall the mock interview today, as well as, your overall collaboration with Margdarshan? Yes, Devraj.
Actually, uh, actually, this is my second mock interview. From the first mock, I have improvised myself. As per the pattern, and Jay sir and Subodh sir has given me so much guidance. They have find some faults. I will rectify from next mock, and I think this is the best platform where else we can practice mocks and GTNP. Thank you, sir.
Okay. Yeah. Thank you, Devraj. So you please now switch off your camera, and we'll move on to next one. Okay. Thank you. कौन आएगा? उसके बाद कौन आया था? बिपाशा आप आए थे उसके बाद, या आशुतोष आप आए थे? I don't exactly remember.
I also
Sir.
don't remember.
अच्छा, आशुतोष आ रहा
Yes,
है.
sir.
अच्छा, शायद आपका उस दिन लिया था ना? हाँ, पहले ही
yes,
लिया
sir.
था.
Yes,
I
sir.
remember. Yes.
Yes,
चलो
sir.
ठीक है, आशुतोष आप आ जाओ. बिपाशा, you will be next. Okay.
Sir, I have not prepared HR side. I have prepared today only technical side. So
चलो फिर HR ले लेते हैं आज.
नहीं
Let's
सर,
say how.
HR नहीं करके आया हूँ, टेक्निकली करके आया हूँ. लास्ट टाइम आपने क्वेश्चन सिर्फ थर्मल साइड से पूछा था.
हाँ
इस
हाँ,
बार मैं एक्सपेक्ट करके आप थोड़े डिजाइन सेक्शन से कुछ क्वेश्चन रखें.
चलेगा चलेगा, क्यों नहीं. तो ठीक
और थोड़ा
है.
सा सर थोड़ा सा हार्ड कोड टेक्निकल में चले जाइएगा.
सी, जा सकते हैं, बट ट्रस्ट में वो यूज नहीं होगा.
नहीं सर, मतलब क्या है ना कि एक्चुअली मैं ना ये परमाणु बैच ज्वाइन नहीं कर पाया था, तो थोड़ा सा मुझे उसकी भी प्रैक्टिस की जरूरत है. तो
अच्छा,
इफ यू विलिंग देन यू कैन.
हाँ ठीक है, मैं कर सकता हूँ, उसमें कुछ नहीं. पॉइंट इसकी सी, जो ये BRC, इसरो, DRDO छोड़ के बाकी जगह पे ना टेक्निकल उतना घुसते नहीं है. आई विल बी वेरी
यस
ऑनेस्ट.
सर.
इंटरव्यू का
यस सर.
ड्यूरेशन भी छोटा होता है, 20 मिनट का यूजुअली होता है. उसमें से भी पहले 5-1 मिनट थोड़ा टेल मी अबाउट योर सेल्फ, वाई HPCL, वाई IISL, इसमें चले जाते हैं. और उसके बाद भी लेट्स से तुम्हारा कुछ फाइनल ईयर प्रोजेक्ट है, कुछ वर्क एक्स है, उसके रिलेटेड हो जाता है. सो
यस सर.
you can, but I'll suggest, as far as HPCL is concerned, be more on the theoretical side only. Baki, let's see. Okay. Yes, Ashutosh. So let's start your interview. Can you please introduce yourself?
Yes sir. Myself Asutosh Kumar. I have completed my BTech from RGP Bhopal in 2023 with the CGPA of 9.07.
So that day, I told you to extend your tell me about yourself.
Sir, no sir, you said ki left your introduction of your siblings and parents, only introduce yourself.
Yes,
Okay.
but it should be a little bit more. That's what I'm saying. See, I have it even written. Okay.
Yes sir. Yes sir. I exactly recalling what you said.
Yes. So what happens is, your introduction should be of such a depth, not too depth, but at such a depth that some question should be, I should be able to ask you some question based on that. Okay.
Yes sir.
Try to do, because वरना क्या हो जाएगा, वो एक abrupt pause आ जाता है. For example, मुझे अभी आया. Now I don't know where to start.
Okay. Sir, in between I have one question. Can I
Okay.
ask?
हाँ, please please.
सर, आफ्टर कंप्लीटिंग माय बीटेक मैं मास्टर कर रहा था, फिर
ठीक
मैंने
है
2 महीने बाद ड्रॉप कर दिया. मास्टर
ठीक
कर
है.
रहा
हाँ,
था.
वो तो बताओ मत, वो छोड़ दो. हाँ, वो मत बताओ.
हाँ.
मतलब कुछ ड्रॉप किया है तो वो मत बता।
Yes, sir.
तो ठीक है, कुछ फाइनल ईयर प्रोजेक्ट का बता दो कि हाँ माय फाइनल ईयर प्रोजेक्ट वाज दिस,
Yes.
वो ऐड कर
After
सकते
CGP,
हो।
I did that final year project.
हाँ फाइनल ईयर प्रोजेक्ट मतलब क्या होता है ना, थोड़ा एक डायरेक्शन मिल जाती है, दैट्स ऑल। बाकी मतलब ऐसा कुछ नहीं है, यू कैन हैव योर वे, बट जस्ट 2 लाइंस का हो तो थोड़ा लगे
Yes, sir.
तो हाँ मदर फादर का ऐड कर सकते हो कि हाँ माय मदर इज दिस, माय फादर इज दिस। सो
Okay, sir.
माय नेम इज आशुतोष कुमार, आई एम फ्रॉम XYZ, माय मदर इज दिस, माय फादर इज वर्किंग हियर, I did my BTech from XYZ, my final year BTech project was this.
Okay, sir. Let me. I am introducing again myself.
Okay, please.
Okay. Hello, sir. Myself Asutosh Kumar. I have completed my BTech in 2023 from RGP Bhopal with the 9.07 CGPA. My final year project was mini conveyor using Geneva mechanism that I have built a prototype. And it is my final year project. And apart from that, my father is a government school teacher and my mother is housewife.
Yes. So at least now I have something to ask you from. So because this was your directly impromptu, so what I'll do is next time whenever you come, improve your fluency. Okay. I know this
Yes,
was
sir.
your first time. That's totally all right. You are doing this, the whole final project. But now you write it down and then revise it, and have a little very soft and smooth. You tell me about yourself.
Yes, sir.
Okay, great. Now why HPCL? Why do you want to join HPCL, Ashutosh?
Sir, last time that question you have asked and I give answer like something. I have preparing it, but I have not currently prepared very well. So can we skip this question next time?
ठीक है, see, I don't mind skipping it, but don't do anything like that. Okay, you had few days.
No,
I
sir.
even asked you to get back to me
I
because see, मैं तुम्हें स्ट्रेस टेन कर्व के बारे में पूछ लूंगा, बट मैं इसकी गारंटी नहीं ले सकता कि ये क्वेश्चन तुम्हें पूछा जाएगा या नहीं, बट आई
okay,
कैन
sir.
गिव यू 100% गारंटी कि why HPCL क्वेश्चन विल बी आस्क्ड टू यू।
Yes, sir. Yes, sir.
ओके,
Yes,
यस,
sir.
सो हैव अ गुड आंसर प्रिपेयर टू इट। मैं कितना भी टेक्निकल में घुस जाऊँ, मैं भी तुम्हें गारंटी नहीं दे सकता कि वो पूछा जाएगा। ठीक है।
Yes, sir. Yes, sir.
हाँ, सो
Yes, sir.
दैट्स आई मीन वो थोड़ा लिमिटेशन होता है, HR क्वेश्चंस आर वेरी डायरेक्ट, वेरी जनरल, वेरी नॉर्मल। सो
Yeah.
एनीवे, यस आशुतोष, सो व्हाट आर योर स्ट्रेंथ एंड वीकनेस?
Sir, my strength is very good technical knowledge and leadership quality, and my weakness is overthinking.
And that's nice. I mean, you have very good strengths actually. So can you give me some example where you had to use your leadership quality? Because HPCL job is not a pure technical one all the time. Sometimes you have to manage people, you have to manage place, you have to manage a refinery or something like that. So can you give me some example where you used your uh, leadership
Sir,
quality?
for leadership quality, I am the captain of my school cricket team, and I have played. We have played very well, and we, as a team, won also intra competitional trophy. And
Oh,
apart from that, I am also vice president of student union in my school.
that's actually nice. So Ashutosh, tell me one thing. Okay, so let's see. You have a beam and it is
Yes, sir.
fixed on the both the ends, something like this. Okay, and there is a
Yes,
beam in between. Can you please draw it for me?
yes, sir.
Great.
I am.
Now, right now there is no tension, no compression, nothing. Now what
Yes,
happens is, I heat up the beam.
sir. In stress generated, thermal stress generated,
Which type of stress?
thermal stress.
Thermal stress.
It will be compressive in nature.
Correct. So, I mean, to be honest, there is nothing like thermal stress exactly. That's just a name we give because it's driven due to something thermal, something related to heat. But yes,
Yes,
it will be compression. Will there be any portion in the beam where stress will be not compressive in nature?
Sir, no, there is no person, any person in thermal in case of thermal stress.
Okay, great. So will the thermals will the tensile will the compressive stress that you are talking about, will it be same
Yes, sir.
everywhere in the beam?
Uh, yes, sir. Because since reaction force everywhere is same, therefore compressive stress will be everywhere same. Since
Okay,
if the since cross section of the beam is same.
correct, correct. Now what you are essentially talking about is little ideal scenario. Now imagine
Yes, sir.
what will happen in a real scenario. There is a beam in between two fixed supports, and I heat up the beam. What happens?
Sir, there might be expansion, slightly expansion of the support.
No, no, support is fixed. Okay, you don't need to worry about that.
Then if we hit the beam apart from compressive stress, there should be buckling stresses, buckling force also. Beam might be
Correct,
buckle.
correct. It might buckle, and what will happen if it buckles?
If it buckle, then there comes then it comes in picture shear force, transverse shear force.
Okay, transfer shear force, fine. And what happens with the length of the beam?
Length of the beams will increase
Correct,
due to buckling.
correct. So that's what I was talking about. And also, I had asked you how will the compressive stress, compression stress in the beam will work in the sense, will it be same everywhere? Now, if given that it is buckling, will it be same everywhere?
Yes, sir. Since reaction since at the both fixed and reaction force will be same. And in our calculation, we simply use a force P acting at the end of column.
See, don't go too much with the calculation here, like how we do it. But if you draw it, you can just understand, okay, can you draw the buckled beam diagram? I mean,
Yes, sir.
given the beam is
Okay.
buckled, can you draw it?
Okay. Sir, I am drawing it in vertical plane.
Okay, please.
A beam is vertical and fixed from both top and bottom.
Mm-hmm.
Okay.
Mm-hmm.
And if we increase the temperature, there should be a sine loop kind arrangement.
Okay. Sine loop
Uh,
yeah, that is true.
can I
So, can you draw it and maybe
can
show
I
it to me?
okay, okay. I'm showing it. So since I am from phone, okay.
That's okay.
So 1 second, my
I think
camera
उस
is
दिन भी
blur.
यही प्रॉब्लम था, हाँ।
कैमरा
और शायद तुमने बैकग्राउंड ब्लर किया है ना, उस वजह से होगा।
अब ठीक है।
हाँ, correct. So the one on the right side is the buckled one, right?
Yes, sir.
Correct. So can you see that the compression stress in the right side of that particular threads, of the beam, that will be less than the inner ones?
Yes, sir. Yes, sir.
Yes. So that's what I was talking about actually, that, the
In this
stress,
thread, one side fiber will be in compression and one side will be tension.
we can't really say it will be in tension because, because due to the thermal expansion, it is still in extended zone. So it could be in tension, but we cannot comment about it right now.
Yes,
Did you
yes,
understand
exactly.
that? Because they
Yes,
already they are extended and then we are compressing it, though we cannot be very sure about that. But yes,
yes, yes.
some in some case this could be the case. Yes.
If the length increase is much greater, then it will be in tension.
Correct, correct.
Other.
Usually what happens is length increase due to buckling is not much. Usually.
Yes, sir. Yes.
So
Yes.
that's why. What is the ratio that we talk about in buckling?
Ratio.
There is one very important ratio in buckling that doesn't arise in any other calculation.
It is equivalent length.
No, equivalent length
Uh,
is for calculation actually. Some ratio
let
I'm
me
talking about.
let me think 1 second.
Yeah,
I
yeah,
have
take it.
no.
You do, you know what I'm talking about.
Yes, sir. I know its symbol. It's a lambda, and I am
Correct.
not actually recalling its name. What is lambda? Lambda is, it's a lambda, or its value is LE by K, where L is equivalent length and K is radius of gyration.
Correct.
And I am not recalling its name right now. Sir, if you guide me, please.
It's slenderness ratio.
Slenderness ratio.
Correct,
Slenderness
correct. So,
ratio.
yeah. So, and it is also calculated for buildings as well. You know, nowadays buildings are getting really high and high. So,
Yes.
to see exactly how the wind will bend the building, they also talk about slenderness ratio. But anyway, I'm just talking about. Yes. So, you know, we have springs. Springs are used everywhere. Okay.
Yes, sir.
Essentially, what
Yes, sir.
spring does is, even if we compress it or, you know, tense it, it offers us the reverse force to what we did. So what exactly is the basis of this particular force in a spring?
Sir, it's transverse eccentric loading.
Okay.
Spring
Mhm.
spring compressed due to transverse eccentric loading.
And that is correct. So, you know, if let's say I tense a spring, it offers the reverse force of compression. Where
Yes, sir.
does this compression force comes from? That's what I'm asking. Do you know?
Sir, it's due to their strain energy. If we tend the compressor, their strain energy is high, and if we try to lose the contact, its strain energy try to pull it backward at their natural state.
Correct. Now, which type of strain energy it is? You know, we have various type of strains. We have shear strain, we have tensile strain, we have compression strain. What kind of strain energy is this,
Sir, it's a shear strain energy.
and how?
Sir, because in spring the expansion is if we are talking about open coil helical spring, their expansion is due to torsion, not due to axial force. Therefore, it's a shear strain energy.
Correct, correct. So that's what I was expecting actually. That's good. Okay, so currently the premium